Now, our topic today is transfer of heat. And don't forget, in our previous video, we have defined it as a form of energy that transfer from one body to another as a result of temperature difference, or form of energy that transfer from hot body to cold body. And we stated the effect of heat. And one of the effects of it is that it changes the state of matter. That is, it can change body from solid to liquid, and it can change body from liquid to gas. When body is changing from one state to another, so the temperature of that body will remain steady. That is, the temperature will not change. Why? Because the heat they are supplying during that period, that substance is using it to change from one form to another, and that kind of heat is called latent heat. That's why we have two types of latent heat. We have latent heat of fusion and latent heat of vaporization. When solid is changing to liquid, that is latent heat of fusion. But when liquid is changing to gas, that is what? Latent heat of vaporization. And you may be asked to define boiling point. Liquid will not boil if the vapor pressure, the vapor pressure on the surface is not equal to atmospheric pressure. Therefore, boiling point is a point at which the saturated vapor pressure of the liquid is equal to atmospheric pressure. Now, the next thing is the stages, how substance change from one form to another. Each stage has its own specific name, and it used to come out in Y question. So when, as you can see from the diagram, when solid is changing to liquid, we call it what? Melting. Then that is when you are supplying heat. When you supply heat to solid, it will change to what? To liquid. Check the diagram very well, and we call that stage melting. Then when you remove heat from liquid, so liquid also will change back to what? To solid, and that is what? Freezing. Then when you now supply heat to liquid, it can change to what? To gas, and the process is called evaporation. When you remove heat from gas, gas also can change back to what? To liquid, and the process is called condensation. But we still have some material that will change directly from solid to what? To gas. And the process is called sublimation. Example of that is camphor. So if you drop camphor on the table, just even without supplying any heat, the normal heat surrounding it will change it to what? To gas. You will not see anything. You will not see liquid at all. It means it has changed directly to gas, and the process is called sublimation. Then the gas also, when you remove heat from gas, it can change directly to solid, and the process is called deposition. Now let's move to the topic of today, which is what? Heat transfer. What are the methods by which heat can transfer from one point to another? We have three ways by which heat can move from one point to another. So heat can travel through a solid material, and the process is called conduction. That is through solid material. Then when heat can also move through either gas or liquid, that is through fluid, and the process is called convection. So it's what? Either liquid or gas. And I said we have three methods, and I just stated two. It has covered the three states of matter. So what of the third one? It can also move through an empty space without any material medium. One common example of it is how heat from the sun reaches our body. When you are standing beside fire, you see that you'll be feeling heat, and before you know, your body will get hot without any material medium, and the process is called what? Radiation. That is the third one. So when heat moves through an empty space, we call it what? Radiation. Let's go and study this one alone. Conduction. And the material is called conductor. Solid material that can conduct heat energy is called conductor. Why those ones that cannot conduct, we call them what? Insulator. Therefore, we divide solid material into two. We have, that is in case of heat, we have conductor of heat and what? Insulator of heat. So this conductor, generally metals, but this one, wood is part of it. Then we have plastic. Now, can we now say this conductor is better than insulator? Both of them, they are useful. Now, if you look at our cooking utensils, they are made up of what? Metal. Why? So that they can conduct heat to whatever we put inside there. If they are not conductor, it means we cannot cook, we cannot prepare our food. But for the insulator, so if we assume that conductors are good because they can conduct heat, then can we now say insulators are not good? Then insulators are also good. They are good in their own aspect. Especially when we are talking about the handle of our cooking utensils. As our cooking utensils are made up of metal, if the handle is also what? Made up of metal, automatically when the pot is get hot, we find it difficult to handle or to carry. So in that case, the handle was made up of something that will not conduct it. So automatically, these insulators are also good in their, most of our cooking utensils, their handle are made up of what? Either wood or plastic. Then we have rod. Look at the rod. Our rod. So when look at concrete floor. Concrete floor is a conductor. When the weather is cold, when you step on it, you feel cold. But if it is rod, it will feel warm, to keep us warm. You can see the importance of insulator as well. Then what of our roof? The roof of our AC room, our air conditioner room. If you on your air conditioner in the room because you want the room to become what? Cool and cold, then and the roof is made up of conductor. The conductor there, if it is conductor, it will be conducting heat. So you will not feel the impact of the AC you on. That's why most of the time when you on your AC, they will say close the windows, close the louvers. But the roof is made up of what? Insulator that will not conduct heat from outside to the room. So those are the examples of applications of insulator as well. So the next video will be the applications of convection and radiation.